We now have a new graph here. Let us just write down what is our general formula, and that is y equal to k over x minus p plus q. We said that if k is positive, which in this case it is, k is 1, it is positive, so then we'll end up in the first and the third quadrant. So in this case my p is equal to 2 and my q is equal to 3, so the blue graph is the green graph, the mother graph, shifted 2 units to the right because p is positive, and then to get the purple graph, that's just one in between, so we shifted 2 units to the right, and then to get the blue graph we must also shift 3 units and then shifted 3 units up. So we're going to shift up because q is positive and p is also positive. So p positive means we shift to the right and q positive means we shift up. So what is the domain? The domain is everything except the value 2, and the range is everything except 3. So I have my vertical asymptote x equal to 2 and my horizontal asymptote x equal to 3. Again, I will just take whatever is in the domain, which is my x minus 2, and I will add my q value. And I will have minus what was in the denominator plus my q value, which can simplify to these two equations here. If I look at my graph, this is my mother graph, the broken lines here. So to get to the purple graph from the mother graph A, I want to shift 2 units to the right because my p is equal to plus 2. And then my q is equal to plus 3, so then I must move 1, 2, 3 units up, and then I reach my new vertex there, which is in this case from 1 to 2 units there is 3, that is the value 3 there, the x value is 3, and from 3 units up will give me 4. Because previously it was at 1, 1, and if I say 1 plus 3, then I get 4. The same with this line here. If I move 1, 2 units to the right, 1, 2, 3 units up, then I reach my new line of symmetry, and the same for the other one, which is this one here. And if I say 1, 2 to the right and then 1, 2, 3 upwards, then I will reach my other line there. The same with my other vertex. If I take B, minus 1, and I move 1, 2 units to the right and then 1, 2, 3 units up, then I reach my new vertex there. So everything is just shifted 2 to the left and 3 up. Okay, what we also see here, this blue graph has an x-intercept, and it is here near the value of 2. Work it out, and it has also a y-intercept of, it looks like 2.5 there. So the y-intercept 2.5 and x-intercept here. Let us work that out. To get the numerator here, I must do 1 from there, 1 from there, plus 3 times the denominator, which is that. If I simplify that, I get 3x minus 6 plus 1, which gives us this 3x minus 5. So y will only be 0 when 3x minus 5, the numerator, when that becomes 0. And that will happen when x is equal to 5 over 3. The y-intercept happens when x is equal to 0, that we plug into y equal to 1 over 0 minus 2 plus 3. Now, the first part is negative a half plus 3, and that will give me 5 over 2. And that corresponds with what we have here. We could not read off that 5 over 3 accurately here, but this is my x-intercept, 5 over 3, which is here. This is 5 over 3, and this is my 5 over 2 for my y-intercept. And there is my graph. So, in effect, I can just do my shifts, plug, put the vertices in place, and then draw the graph, the blue graph, and also the vertical asymptote, horizontal asymptote, as well as the axis of symmetry. All of that you can do by doing shifts.